Hello students, and welcome. This is Dr. Sami, and in one of my previous videos I did KCSE 2021 paper 2 question 1 to 8. For this one we do question number 9 to 16. Here are the questions. Question number 9, question number 10 and 11, question 12, question 13 and 14, question 15 and 16. Well, in one of the previous uploads, I had posted the whole paper, but this one I've posted the 8 questions that I will do. I will start from question number 16 all the way to question number 9. With the question number 16, you're supposed to do something called integration. We are doing integration. And what exactly are we asked to do? The student was expected to find the area. You know, this is just a sketch I've done. The area between the curve, or that is enclosed by this curve, and the x-axis from the point x equals to 1, x equals to 3. So basically we're finding the area under this curve there. So the student was supposed to integrate. You integrate the function that you're given with respect to x. And remember, you're given the definite integral from 1 to 3. And with integration, you add the power 1 there. Then, of course, the sum power there, you divide. That's what exactly I've done here. The x cubed over 3. It is just basically 2 plus 1 over that 3 here. Then over here, the power is 1 plus 1 over 2. So 2 and 2 will go, x to power 2, x to power 2, then plus c. The integrals remain from 1 to 3. And that's where the student scores the first mark. The next mark is for substituting. The upper integral, you substitute it into the values of x, or where x is. So 3 cubed over 3 plus 3 squared plus c. That is the upper integral minus the other integral, 1 cubed over 3 plus 1 squared, yes, 1 squared x squared plus c. If I do that, remember this will be to power 2. This will be 9 plus 9 plus c, 18 plus c. Then on the other side, it will be 1 plus a third. That is 1 and a third. Then if you do subtraction, it will be 16 2 over 3 square units. And that's where now the student gets the third mark. That's number 16. This question number 15, whereby you're given the area of an object. It is x centimeters squared. Area of the image, 13x centimeters squared. Then you're given the matrix of transformation, x, 7, x minus 1, 3x. The matrix of transformation is there. Now, you are expected to find the value of x. Good. All you need to know, or the student was expected to recall, that the area scale factor is always equal to the determinant of the matrix of transformation. And that is all I've done. The determinant of the matrix of transformation is 3x times x. Yes, 3x times x, you get 3x squared minus 7 times x minus 1. Product of the elements in the principal diagonal, subtract the product of the elements in the other diagonal. That's all I've done. So that is it. And that's where the student scores the first mark. The area scale factor, remember, it is the area of the image over area of the object. Yes, that's all I've done. Area of the image, then area of the object. The x and x will cancel, then I open the brackets. Remember, I'll end up with something like this. If I open here, this is 7x minus times minus plus 7. Then if I reduce that equation, I will end up with this quadratic equation. It's a matter of solving this quadratic equation. I'm looking for two integers such that their product is negative 18. 3 times negative 6, and their sum is negative 7. So for the two integers m and n, they are basically negative 9 and 2. If I can do multiplication, negative 18. If I can do addition, negative 7. So it's a matter of factorizing. We do factorization just like I've done. You end up with the answer. Now, where does the student score? Yes, the other M mark is here, where the question is fully factorized. Then you equate. Remember, I can say 3x plus 2 equals to 0. So x will be negative 2 over 3. Then x minus 3 equals to 0. Then x equals that. And that's where the student scores the other mark. That is question number 15. Question number 14, you're given the position vector OP. You're also given the position vector OQ. You're also given the position vector OR, just like I have given. The student was expected to show that the point P, Q, and R are collinear. That tells you, or that means, they lie on a straight line. They are on a straight line. Good. All that you expected. Look here, my student. If you're trying to show that 3 points are collinear, either you need to work out like the vector PQ, then work out the vector QR. Once you have the two vectors, if one vector can be expressed in form of the other, or rather there is a constant, if I multiply the first vector, I get the second, then the points are collinear. Otherwise, I can still work out PQ, then I work out PR. Then I compare the two vectors. Now, like for this one, I have decided to work out the vector PQ and PR. Vector PQ is given by PO against that direction plus OQ. Basically that, even if I cancel this, I'll end up with PQ. So, with the PO, I'm going against the direction. So this is negative 1. That means against the direction plus, remember now I've extracted just this vector, 6, negative 2, 3. Yes, negative of it because it's against the direction, plus 12, negative 5, 6. Just writing it in column form. So if I can operate this is 12 minus 6 because of this. This is 6. Negative 5 plus 2. That is how I get negative 3. 6 minus 3. I get 3. So this is how the student gets the first M mark. Now, I proceed. Working out PR. It will be PO against that direction added to OR. And just like I did before, negative 1 to show the opposite direction of vector OP. Yes, OP just like it is. Plus OR. Just this vector here written in column form. Just that. So this is 8 minus 6. You get 2. 3, negative 3 plus 2. I get negative 1. 4 minus 3, because of this, I get 1. And therefore, that is vector PR. We come back to vector PQ. PQ is 6, negative 3, 3. This one, I can decide to factor out the common factor 3. Then what remains inside? It is 2, negative 1, 1. Exactly this vector. What does that mean? And if a student can go up to that point, another 1 mark. If I can be able to relate what I can see here, the vector PQ is equals to 3 times the vector PR, because this is vector PR. So there is a constant. If I multiply the vector PR, I get vector PQ. And that is the proof that PQR are collinear. That is where now we get the conclusion. Actually, you get that mark here. Yes, you get the other mark here. Remember that the second mark is here, not necessarily here, because here we have even proven that. So that is another mark, and then the answer mark there. Question number 14. Question number 13, it's a question on loci, or just locus. And loci is all about construction. Mainly, it's all about construction. You are supposed, the student was given the triangle XYZ, like you can see here, And remember, what I'll do is just to give you a guide. Then you, using a ruler and a pair of compass, you can try and do the construction. So the student was to locate a point M that is 2 centimeters from the line YX or XY. Then it is equidistant from the line YX, yes, and the line YZ. Good. With this is as simple as I'm going to guide you. We are talking about a point M that is 2 centimeters from the line YX. And that means it is a line that is parallel to this line, yes, somewhere 2 centimeters. So all the students need to do is to construct a parallel line to this. So standing here, the student extending your pair of compass 2 centimeters, you make a mark. Standing here 2 centimeters, you make a mark. Then join, make like, you know what you're doing. It's like you're having a tangent to this arc, a tangent to the arc, and that one will be 2 centimeters, and that's where the student gets the B1, 2 centimeters from this line, a parallel line to this 2 centimeters. Then we are given that it is equidistant from this line and this line. That is a bisector to this angle. Any point that is equidistant from these two lines, it means it is a bisector. So all the student need to do is to bisect. Standing here, arc, arc. Then over here you make an arc. The same radius, standing here, make an arc. Then join. That is a bisector. These two angles are equal. By doing that bisector, another one, mark. The student was to measure YM. The student was to measure from here to here. Good. If the student did that accurately, YM was 4 centimeters. Remember, the student is given an allowance of 0.1 centimeters. So plus or minus 0.1. And this is where the student scores the third mark. Good. You can take a pair of compass and a ruler, try to locate point M. Yes, you can see that is where the point M is. 2 centimeters from this line, equidistance from these two lines as well. Number 12, a question on probability. And you're given that there is a bag that contain 3 brown balls, 9 green balls. Then 2 balls are picked at random without replacement. So part A, you draw what we call probability tree. Probability tree. Remember, in this case, no replacement. So you have the first picking. If we do pick a ball at random from this basket or the bag, wherever they are, the probability of picking a brown ball, it is 3 out of 12 because there are 3. The probability of picking a green ball, it is 9 out of 12. That is the first picking. If we go for the second picking, the probability of picking a brown ball, remember the first picking was a brown one, so it will be 2 out of 11. Even the total number of balls have decreased. Now, then the probability, the second picking of picking green, it will be 9 out of 11. There are still 9. We have not touched the green ball in the first picking. The second branch here, the probability of picking a brown ball, it will be 3. Remember the first one is green, so 3 out of 11. Then the other one, the probability of picking a green after picking the first one being green, it is 8 out of 11. I hope the student can be able to work out that. For you to score this 1 mark, all the probabilities must be indicated. Part B, the probability that the 2 balls that are picked are of different colors. So where are the different colors? Remember, in this one, it will be like this is probability brown, brown. This one, the probability brown, green. Yes, brown, green. This one will be probability green, brown. Probability green, brown. In this one, this is probability green, green. So where are the two combinations that where the balls are of different colors? Here and here. Just that. So it is the probability brown green, 3 over 12 times 9 over 11, yes. Then 9 over 12, yes, multiplied by 3 over 11. And that is that. So with that, that's where the student scores the other mark. Then working them out, the student gets that. Remember, we say these two occurrences are mutually exclusive. So they are the branches of the tree. The brown and the brown, those two are independent. So they are the continuation of the branch. Otherwise, the student need to revise probability well. That's question number 12. This is question number 11. A question on longitude and latitude. And what exactly was the student given? The student was given a point Q that is to the west of a point P. The coordinates of P were given 41, 55 degrees west, yes, 40 degrees north. You can see the latitude there is 40 degrees north, the longitude 155 degrees west. So there is a point Q that is 2000 nautical mile to the west. And the question was the student to determine the longitude where Q lies. We assume that theta is the longitude difference, the difference between these two longitudes. Now, if we want to find the distance between PQ, it is theta multiplied by 60 cos latitude. And that's all I've done here to equate it to 2000. If the student was able to express theta here, like I've just done, remember it's just dividing this side by 60 cos 40, yes, 60 cos 40, and even this side by 60 cos of 40. By doing that, 1 mark. Good. With that, we get the theta there. The longitude difference is 43.51 degrees. That is longitude difference. We have just confirmed that the longitude difference is 43.51. Remember, if I go another few degrees, like 25, I'll go to the limit of longitudes, because longitudes will go up to 180. 180 west, 180 east. So therefore, I need to work out how many degrees remaining for me to get to 180. It is 25. So 43.51 subtract 25. Yes, to see what angle spills over to the next side of the eastern side. So it is 18.51. Now I can subtract from the limit of the east, 180 degrees, subtract that, I get whichever way the student do, provided the student gets this, 161 degrees east. Yes, the east must be there. Question number 11 done. Question number 10, you're given this trigonometric function that y is 4 sine into bracket ax minus 70. Even before we proceed, if I'm given a trigonometric function, a maybe sine or cos, yes, b maybe bx plus theta. If I'm given something like this a always represent what we call the amplitude. This is the amplitude. Yes, if I want to work out the period of this wave, yes, the period of this wave will be 360 over b, 360 over what is here. Then what they call the phase angle is always theta. So if you know this, you're good to solve this problem. Part A, we find the value of A here. As I've said there, this one will help us get the period. 360 over A, 360 over A, whatever is in here, 360 over A equals to 180. The period of the wave has been given. So with that, 360 over A equals to 180, you only need to solve. Cross multiply. So then divide by 180, divide by 180. A is 2. And that's where the student scores, actually it's just 1 mark. Then we have the face angle. You only need to lift that, and the face angle is 70. 2 marks, easy to get. Number 10. Question number 9 was a question on graph. Yes, this was a graphical question. Mainly, I will not do an accurate drawing. I will just guide the student on how to draw the graph. You are given values of t and the corresponding values of h. The table is well guided. Lucky enough for this time, the student was given a scale. So it was a matter of plotting. This is h, this is t. So when t is 1, h is 8. Yes, there. When t is 2, h is 4. When t is 3, h is 2.7. 2.7. Yes, somewhere there. You know, with your accurate graph, you can be able to plot. When t is 4, h is 2. Yes, somewhere there. Okay, when this is t is 5, 1.6. Yes, 1.6. It's somewhere there. 6, 1.3. 6 is 1.3. 7 is 1.1. Then 8 is 1. So if the student was able to plot this curve, remember mine is just a guide. The curve was supposed to be a very smooth curve, like that, a very smooth curve. If you can do the accurate drawing, you can see. So for the plotting, 1 mark. For the smooth curve, 1 mark. For the 2 mark. Part B of the question, because part A was you draw the graph. The student was to use the graph and determine, correct 1 decimal places, the rate of change when t is 3. So all the student need to do is to come over here where t is 3 and identify that point. Then the student draws a tangent. For the drawing of the tangent, another 1 mark. Now, how do you get the rate of change? It is the gradient of that tangent. For the accurately drawn tangent, this point or that tangent was passing through the point 60, and it was passing through a point 3, and over here it was 2.7. So it was a matter of finding that gradient. Remember now, the gradient will be given by change in y over change in x. So for that case, the change in y, you can say it is 0 minus 2.7, then the 0 2.7, then 6 minus 3. The answer here will be negative 0.9. Remember, there is a plus or minus, maybe 0.1? Yes, 0.1 for the final mark there. That is question number 9. The question on graph will always be fair. Otherwise, thank you so much. Do not forget to come back for more. We are not done with paper 2. We have section 2 to do. Thank you. This is Dr. Sirme. Good. This is a brief highlight or a story of Dr. Sirme academic journey, and the purpose is not necessarily to brag or to show off, but to encourage a student that you can start somewhere, go up to the highest limits that you desire. Dr. Sirme. Primary education. Dr. Sirme went to a very humble school in a place called Molo South, specifically Cresoi. And the school, the name as it is in the certificate, the Dr. Sirme managed a certificate there, KCP certificate, with a score of 490 marks out of the possible 700 marks. That was an average of 70 marks, and that translates maybe to a B plus there. Secondary education, maybe the Dr. Sirme went to a very humble school again, secondary school in Rift Valley, the same place. And as you can see, I managed a certificate or a mid grade of A minus with 3 clean A's, 3 clean A minuses, a B plus, and a B minus somewhere there. That is 79 points. Then Dr. Sirme proceeded for tertiary education in the best university in Kenya, that is the University of Nairobi, and specifically the Chiromo campus. And my best department was the Department of Chemistry. I can remember my good professors, Dr. Shundu, Orata, among others. Actually, had very good chemistry professors and doctors there. Then I managed the 4 years of undergraduate, first year, second, third, fourth, and out of the 52 units that I did, I managed 27 A's, 18 B's, you can see 3 C's, and 5 D's. And eventually, I graduated with first class honors from this university, as you can see there. That is the highest honor you can have, maybe for an undergraduate. Then I proceeded for my tertiary education, and I joined Kenyatta University for my master's in science, especially in chemistry. Then the theory part of it I did, the practical part of it done. Then, as you can see there, the theory performance, well illustrated, all the units done. This is Dr. Sirme, a fully registered teacher with the Kenyan Teachers Service Commission. And for my student, this is just an encouragement that it is possible to start somewhere. It is possible. You can start humble, go up the ladder as you determine to go higher and higher. Then eventually you achieve your dreams. All it calls for is persistence. You be persistent, do not give up, be focused, and remain on the path. Otherwise, this is Dr. Sirme. Keep coming back for more. Subscribe, recommend to students, and like. And this is where you'll get your best